Translating functions. These basic functions are just the beginning of graphing functions. Functions can be transformed to create new functions. This word transformed is a generic term covering a list of movements that a graph can undergo. For example, a graph can be moved left or right. That's a transformation. A graph can be moved up or down. That's a transformation. Rotation, reflection, or even changing the size by shrinking it or expanding it, are all types of transformations. Let's talk about a vertical translation, which means you're going to move a graph up or down. A vertical translation slides or shifts the graph of a function f of x up or down and is given by the formula f of x plus k. When k is positive, f of x will slide up k units. When k is negative, f of x will slide down k units. Let's consider f of x is equal to x squared and two of its translations. Notice that this is in blue and the graph associated with this is also in blue. Now g of x is going to be a translation, which is f of x plus 2 or x squared plus 2. And notice that g of x is moved or translated up 2 units, 1, 2. When we consider another function, h of x, which is taking the original function f of x and subtract 3, we get x squared minus 3. So the original function f of x was translated down 3 units. The graph g is the result when f slides up 2 units. The graph h is the result when f slides down 3 units. For the function g of x equal to the absolute value of x, write a rule or formula for the translated function. We have 4 different translations which we are going to go through and create a rule for each one. The first one, we're going to move it up 3 units. So we'll have the new rule, h of x, was the original absolute value of x plus 3. Notice that the graph of the original function has been translated up 3 units. For letter b, we're going to move it down 1 unit to create a new function, h of x, which was the original function, absolute value of x minus 1. And again, notice the original function has been translated down 1 unit, the absolute value of x minus 1. For letter c, we're going to take the original function and move this down 4 units. So it's going to be absolute value of x minus 4. And notice the original function has been translated down 4 units. And finally, for letter d, we've created a new function where we've taken the original and moved this up 2 units. So the original function was g of x is equal to the absolute value of x. The new function we'll call h of x, which is h of x plus 2. The result is the original graph has been moved up 2 units. Continuing with our various examples of vertical translations, specifically up and down, let's consider f of x is equal to 6x minus x squared. This is the graph of f of x right here. The transformed function g is given by f of x plus k. We want to find the value of k. Well, the answer is that the vertex of f is at 3, 9. Put that in right here. This is the vertex of f, 3, 9. And the vertex of g is at 3, 3 right here. This indicates that f of x has moved down 6 units. Since it moved down 6 units, the value of k is negative 6. So g of x is equal to f of x minus 6. Now we'll talk about horizontal translations, meaning that the graph will move either to the left or to the right. A horizontal translation slides or shifts the graph of a function f of x left or right and is given by f of x minus k. Notice the difference between the notation with a horizontal translation. With a horizontal translation, the constant k is inside the parentheses. With a vertical translation, the constant k is outside the parentheses. Now let's continue on with our discussion. When k is positive, f of x slides right k units. When k is negative, f of x slides left k units. If we consider f of x equal to x squared, given by this graph right here, the graph of h of x is the result when f of x slides right 3 units. notice we have h of x, given by this graph right here, is equal to f of x minus 3. Continuing on with our discussion, this time f of x is still going to be x squared, but our new graph g of x is the result when f of x slides 2 units to the left. So here's the original function f of x denoted by this reddish parabola. The bluish parabola, g of x, is given here. And notice it's gone over 2 units to the left, 1, 2. Now I want to make some remarks about the arithmetic. We set up here that when k is negative, f of x slides to the left k units. So we have this function moving to the left k units, so k is equal to negative 2. However, there's a minus right here. We need to make note of that. When we're using basic arithmetic, x minus a negative number becomes fx plus the number. So sliding the graph 2 units to the left will result in g of x equals f of x plus 2. That's something that everyone should be aware of when we're talking about horizontal translations. For the function a of x equal to the absolute value of x, write a rule or formula for the translated function. This is the original graph of the function, absolute value function. Here are the 4 rules we're going to create. Create a rule when this original graph is translated 3 units to the right. Next, we're going to create another rule when this original graph is translated 1 unit to the left. Also, we will create a rule when this original graph is translated 4 units to the left. And then finally, we're going to create a 4th rule when this original graph is translated 2 units to the right. When the function is translated to the right 3 units, the new rule we create is g of x is equal to the absolute value of x minus 3. Now let's analyze this a little bit. Remember that in general, a translated function will be f of x minus k, where k determines whether or not how far the graph is translated left or right, whether it's positive or negative. Since we're moving 3 places to the right, k is positive. So it's going to be a positive 3 because we're moving 3 places to the right. So I substitute k with 3, and that's how we get our new function, our new rule, g of x is equal to x minus 3. In the second case, we're now going to move the original graph 1 unit to the left. This is the original graph. We're going to move it 1 unit to the left, which means that in our general formula, we have f of x minus k. We're moving it 1 place to the left, so k is equal to negative 1. Negative indicates we're moving it to the left, and the number 1 indicates how many places we're moving it. So when I make my substitution, we're going to have, getting more specific, this is now a of x is the absolute value of x. So our new function g of x will be g of x is equal to the absolute value of x minus negative 1, which is how we get this new function. G of x is equal to the absolute value of x plus 1, since in arithmetic, 2 negatives make a positive when they're near each other like this. Now for our third case, we're moving this original function 4 units to the left, which means our value of k is equal to negative 4. So the translated function a of x, which is equal to the absolute value of x, becomes g of x, which is the absolute value of x minus a negative 4. X minus negative 4 is also x plus 4. So our simplified or final rule will be that g of x is equal to the absolute value of x plus 4. In our fourth and final example, we are going to translate the original graph to the right 2 units. So this is the original. We're going to go to the right 2 units. Remember that in general, a horizontal translation is f of x minus k. And in this case, since we're going to the right 2 units, k is equal to positive 2. So our translated function is going to be g of x, which is the original function, absolute value of x, minus k, where k is equal to 2. So our final rule that we've created is g of x is equal to the absolute value of x minus 2. In this example, we're going to let f of x equal 6x minus x squared. The transformed function g is given by g of x is equal to f of x minus k. Our goal is to find k. And here's the answer. The vertex of f is at 3, 9. Now 3, 9 is located right here. And the vertex of g is at 6, 9 right here, which indicates that the function moved 3 units to the right, so the value of k is equal to 3. We'll notice here's the vertex. We go 1, 2, 3 units to the right. By the way, every point on the function moved, or on the graph of the function, moved 3 units to the right. So if I have my x-intercept here, I go 3 units to the right to get another x-intercept. If I have an x-intercept here, I go 3 units to the right to get the other x-intercept. So all of the points on the graph is translated over to the right 3 places. The value of k is 3.